All right, here we go. I'm going to have a quick little lesson on just some of the characteristics and facts about the relationship between f prime and f double prime. So if we have some function, f of x, we know that the derivative is f prime of x. And the second derivative is f double prime of x. And facts about f prime and f double prime actually give us information about f, the original function, as sometimes it's stated. For instance, if f prime of x is positive, we say that it's greater than 0, we can say that f of x is increasing. That's the more formal way of saying the function is going up. If you're looking at a graph from left to right, if this is f, should have used a capital F, that function is increasing on this interval. If f prime of x is less than 0, also known as negative, if f prime of x is less than 0, then we can say that f of x is decreasing. And there's only one number left we haven't considered, the only number that's not positive or negative, and it's if f of x actually equals 0, then we can say that it's neither increasing or decreasing. And this is going to lead to some other conclusions. The main one being that if f prime of x is in fact a 0, we have a potential maximum or minimum. Erase this over here real quick so I can add a little picture. The reason I say potential is that if we have some function, we'll call this f, and we think about this segment, that function is increasing every spot that line is red. But if you think about the derivative or the slope at that this value that we'll call c, f prime of c is equal to 0. And that means that there is a maximum there. You can see that the graph hits a high point in that neighborhood of c. But if you look at this value, d, this particular slope, right, f prime of d, is also 0. But one of those spots is a maximum and the other one is a minimum. And so we need to kind of figure out some ways where we can distinguish, or, how do you find a max or a minimum without actually being able to graph it. There's also a third scenario, right? There's this word potential over here. But there's this third scenario where you could have, a graph coming up, and there's this moment where the tangent line or the derivative, my graph's not perfect, but the idea is that at the origin, the slope is 0 there for just a moment, an instant. You could think of the function x cubed if you want to put an actual function on it. And that derivative is 0, but it's not a max or a min. And we actually call this a plateau. And so we have 3 cases where when the derivative at a value is equal to 0, one instance gives you a maximum, one instance gives you a minimum, and a different instance gives you neither a max or a min, but you have a plateau. And we haven't even mentioned where the derivative could be undefined. If you have some type of cusp. It's supposed to be sharper. Oh my gosh, it's getting worse. There's a maximum up here, but really the derivative is undefined, so we need to accommodate that also. So one way to think about this is to consider the behavior around a point. So let's look at an actual example. We'll start with an easy one. So this is a parabola, and specifically it is a parabola that has this shape. We know that because the leading coefficient is positive. And so if we want to determine where the maxes and mins are, or if this has maxes and mins, I picked an easy example because if you know the shape of the graph, you can kind of predict that it's going to have a minimum. But where actually does that happen? So one of the common things we're going to do, that it's kind of one of the catchphrases for the class, is set the derivative equal to 0, set the derivative equal to 0, set the derivative equal to 0. And if you think about taking the derivative, power rule, and setting the derivative equal to 0, and then actually solving for x. We set the derivative equal to 0, we solve for x, and then what in the world did we find? So remember, if f prime of x is equal to 0, we have a potential max or minimum. So we found an x value. If we graph this, we could get an accurate graph, but what in the world did we find? So one thing that does come up that's kind of handy, and we're going to need a strategy when the functions get a little more tricky, is sometimes called like a sign chart. So if we make a little table with x values and f prime of x values, and we throw 1 kind of right smack dab in the middle here, and then we look at a number to the left of 1, something smaller than 1, and something larger than 1. We essentially want to look at the derivative, right? Derivative, the slope around that value. Look at the behavior. So what do I mean by that? F prime of 0, again, substituted in here, is -2. We know f prime of 1, again, plugged in here, is 0. That's what we found over here. And if I substitute 2 in, I get 2. You can see the symmetry of a parabola. But more specifically, just think about the interpretation here. If the derivative is negative, that means that at that point, the graph is decreasing. That means that the slope is negative. That means that the graph is going down. We don't want to say it's going down. We can say it's negative, it's decreasing. That's a better way to say it. We know at 1, the slope is 0. That's a horizontal line. And then we know that at 2, it's increasing because this number is positive. To some people, this might look like gibberish, but really, if you think about the parabola, we just talked about how it's decreasing, it's 0, and then it's increasing. When you have a sign change that goes from negative to positive, when the sign of f prime goes from negative to positive, that is a concrete way to determine that you have a minimum. And I misspelled minimum. Minimum. But, so that's when you have negative 0 to positive. But if you think about another type of function, if your derivative around some point, we're going to find out very soon that these are called critical points. When you find out that the derivative goes from increasing to 0 to positive around some point, you can kind of see the structure develop. And when you have that behavior of increasing, 0, decreasing, that's where you're going to determine that you have a maximum. When you get into some functions that are a little bit more sophisticated than perhaps a parabola, and again, I love parabolas, but if you have something like this, you can have functions that have multiple maximums, multiple minimums. You could also have functions like e or something exponential that have no maxes or mins. You know, it doesn't ever hit a high point. And so there are some details to work out that we're going to spend some time on. But this is just kind of a nice little way to get situated with the basics of maxes and mins. So thanks for checking this out. I'm using a new tablet. This is my first go around, so sorry if my voice is a little scratchy. We'll work on that. So thanks for watching.